All right, today we're going to tackle a storage warehouse under other occupancies. This is sort of more of the same in the way of, we've dealt with houses, apartment blocks. Here we're just basically adding up the watts, setting them up, knocking them down. More of the same, but it's a little combination of everything, similar to what the apartment was. So let's just go through it and take it one step at a time here. So we have a storage warehouse set up. It's 160 feet by 140 feet. It has an office area that's 35 feet by 40 feet. And notice that this is in feet, not meters. Demand factor is 100%. This is relative to the conductors, some of the feeders, or the service. We're just taking everything at 100%, meaning there's some values we won't apply in table 14. The service is 120, 208 volt, 3-phase, 4-wire, meaning there's an A, B, C phase and a neutral. And we're going to parallel the service conductors by 2. So we have a few loads here. We have some loading bay doors, 1 horsepower, 208 volt, 3-phase. There's 3 of them. Air handling units, 5 horsepower, 208 volt, 3-phase. There's 1. Warehouse fans are 1.6 horsepower, 120 volt, single phase. We have 8 of them. Receptacles is going to be 12 515Rs, 3 520Rs, 1 1430R, and a locking 2130R receptacle. It is 3-phase, so just be aware moving forward how this is going to work out. The warehouse lighting is good for 20 kilowatts, additional lighting 6 kilowatts. We have a load center, meaning a panel through 3-phase, 120 208 volt, a sub panel, good for 200 amps, and we have 5 restricted parking stalls. The conductors are TW75, meaning it's a 75 degree rated connecting temperature, and again, the code book always assumes that the equipment is not marked. So that would be 4-006 in that case, but in this case, we're dealing with TW75, meaning that the equipment is marked for 75 degrees. And again, just playing with some numbers moving forward, we'll see some R90 conductors, or sorry, T90 and things like that. 90 degree rated conductors essentially. And that'll be that. So we're going to apply 8104 for the surface conductors, and for this one we're going to install the overcurrent protection according to the next standard size overcurrent device. And you'll see what I mean when we get to the end. So here, when we look down this calculation here, we're 8210 subrule A deals with table 14. We're going to use the metric units in here, and we're going to apply, that's the MU, metric units, and we're going to apply 28010 for our motor loads. So the storage warehouse here, we have, and in the handouts, I have the answer keys laid out and all that kind of thing, similar to what you're seeing here. The storage warehouse is 160 feet by 140. We're going to multiply that because we need to get our square area. It gives us 22,400 square feet. Now we have to convert that all into meters squared, because that's what our table 14 is based on. So we're going to take the square feet and we have to convert it. So the metric unit table is giving us the 10.764. So we're going to take 22,400 square feet divided by 10.764, and that'll give us 2,081 meters squared. And for the storage warehouse, we'll see in table 14, if you notice storage warehouse, it's allowing 5 watts per meter squared. So we have 2,081 meters squared by 5 watts per meter squared gives us 10,405. More of the same for the office area, 35 by 50 gives us 1,750 square feet divided by 10.764 gives 162.5 meters squared. And we'll see for the office area, it's indicating again in table 14, 50 watts per meter squared gives us 8,128.9 watts. The loading bay doors, 1 horsepower, 208 volt, 3-phase, gives us table 44. you'll see that this motor is 4.6 amps. We'll multiply that by 208 times the square root of 3. And again, we're always using PEI for code. We're adding all the watts, right? And according to 8100, once all the watts are adding up and we calculate for current, we're going to apply the voltage. So that's why everything's getting converted into watts here. So we end up here, there's 3 loading bay doors, so 4,968 watts. The air handling unit, there's 5 horsepower, 208 volt, 3 phase, table 44, 16.7 amps times 360. Now 360 is 208 times the square root of 3, just approximated. Just giving you a different version there, so times 1, so we got 6,012 watts. Warehouse fan, 16 horsepower, 120 volts, single phase. This is where you got to be aware here, table 45, so we got 4.4 amps. 120 volt times 8. Gives us 4,224 watts. So we have receptacles. We're just going to sort of set them up and knock them down. We have 515 Rs, so that implies the 120 volts. So we got 120 times 15 times 12 of them gives us 21,600. 120 times 20 for the 520 Rs gives us 7,200. 208 volt, because it's a 208 volt system. 30 amps for the 1430R. It's 208 volt because that is our phase voltage. Typically in our labs we deal with 240 volt. So we have 6,240 for that. And then here our locking receptacle is 3 phase. So we're going to go back to the 360 volts, right? 208 times the square root of 3 times the 30 amps gives us 10,800 watts. The warehouse lights, and from this point on everything's pretty much laid out for you here. The warehouse lights, I've given you the values, 20,000 watts, additional lights 6,000, load center, we're just going to take that at 7,200. So it's 208 times 200 there, so we got 1,000 watts. And now our restricted parking stalls, 8,400, subrule 4. Subrule 4 is linked to the restricted. There's subrule 3 is unrestricted. Gives us 650 watts per stall times 5, so we got 3,250. So we're going to add up all of these watts and we get a total of 180,827.9. So we're going to track down our current. We're sizing our conductors and our overcurrent for the main service. So divided with, start down the dark path here, divided by 8100 divided by 360, and again that's 208 times the square root of 3. Gives us 502 amps. We're going to, it's considered continuous. 104 6A gives us 80% because this is going to be in conduit. I forgot that right at the beginning here. This will be conductors TW75 in conduit. And I'll make that little note right here, in conduit. In conduit is code for apply subrule 6A. And now here we have, so I mentioned at the beginning, install overcurrent protection according to next standard size. And what that means here is, so we can go one of 2 ways. I've mentioned this before when we deal with paralleling. We can just take this value, size the conductor, so we to 0.8, so we end up with 627.8 amps. And then at that point, we would parallel before we size our conductor. So if that's the case, we have 313.9. And if we just ran down this sequence, you would have 4-0041B table 2, conductors are copper, 400 MCM at 2 per phase. 14104, 600 amp minimum. Okay, so we can sort of express it that way. 400 MCM is good for 335 amps in the 75 degree column, so we'd be good, 335 times 2 gives us 670 amps. You'll notice in table 13 it goes from 600 to 700 amps. So you could say here, again, depending on the engineering and whatever, 600 amp minimum. We can make all sorts of statements, right? This is code, so nothing's really locked in stone here. But at the end of the day, we have a couple options. So 400 MCM, good for 670. So you can say 600 amp minimum. Or at this point, we can go into the next standard size, NSS, next standard size. And so 627, if we go to the next standard size overcurrent device, we look at 700 amps, and you'll see that in table 13. So we can take the breaker size, divide that by 2, gives us 350 amps. And then when we look at table 2, again, because the conductors are copper. We would end up in this case with a 500 MCM at 2 per phase, and then 14104, the 700 amp overcurrent device, which is stated right here. So again, there's a couple of ways that you can express things in code. Nothing is really locked in stone, but here we go, just again, one different way of looking at things. And this is also standard. So that is what we're looking at according to the original instruction in the question. So that's what we'll see there. So I'll just make a note here that the conductors are copper. So that's pretty much it for the way the calculation unfolds. I just want to touch on a couple things here. Where I see errors from students is in these sections here. So 10.764, the divide, a lot of times I'll get multiply by 10.764, which, if you think that through, is going to inflate this number quite a bit, to the point of it being just completely out of range. So be aware, this is one of the errors I see, and again repeated through this part of the calculation. Students will miss the 3-phase, sometimes depending on the load, they'll apply table 45 here, or sometimes they catch the 3-phase, table 44 is fine, we get our values and all that, but they'll forget the 208 times the square root of 3, and all I'll end up with is with the 208 volts being multiplied. So that affects the wattage slightly, but yeah, so that's what common errors, and again, the same error we'll find here with the single phase table 45, the 120 volts. Sometimes it just gets the wrong voltage applied or the wrong table applied, and again, it really has to do more with just taking your time and being aware of what's presented to you in the calculation. And again, here with the receptacle, because it's a 3-phase receptacle, we're dealing with the 360 volts being applied. So right here, this is an L21. So when you deal with these locking receptacles, we're not using diagram 1 anymore. We're using diagram 2. So that's what that's linked to. So 26700, when we're dealing with receptacles, sends us to diagram 1 and 2. So here, that's where you'll find the configuration for this receptacle, and it's 3-phase, so that's why we have to apply that. And 8400 subrule 4, this is where I'll find some errors as well from students, is the parking stalls typically aren't applied. I won't see this code. I'll see some watt calculation. So the restricted parking stalls, if I don't give any information here, sometimes a student will just assume 120 volt 15 amp and give me some sort of wattage. So right there, be aware, the restricted and the R, the restricted comes from subrule 4. So it allows for 650 watts per stall, and then we just apply that across however many we have. And that's pretty much it for this calculation. So remember, 8 to 10, subrule A is where table 14, I need that statement there because we're dealing with other occupancies in this case. And we're referencing the metric units for the 10.764, and 28010 is stated here. I don't need 28010 stated over and over and over, right? You can stick your table in, that's fine. But just a reference to the code somewhere once is fine with me. And that is pretty much it for storage warehouses.